FOIL Part 2. What does it mean and why does it work? By Jeff Simpson. Let's look at a simple equation. X plus 1 equals 10. You can think of X as an abbreviation for what number or some number. So what number plus 1 equals 10? Well, for most of us it's obvious it must be 9. And if you put a 9 there in the place of X, you can see that is true. Another situation, x minus 5 equals 1. X must stand for 6. Here's another one. X times 2, some number times 2 equals 10, must be 5. Or some number divided by 5 is 4. 20 fits here. Letters such as X can stand for a variety of numbers. The amount a letter stands for varies. And that's why letters are called variables. A variable plus a number is called a binomial. A variable minus a number is also a binomial. Bi means two in Latin, like the bi part of bicycle. A binomial has two terms. This is a term, x. This is also a term, 3. A term is a number or a letter, in other words, a variable. Two terms being added or subtracted is called a binomial. There were some binomials. Nomial means named in Latin, and a binomial names two terms. Multiplying two numbers can look like this or this, and we can even picture it as 3 groups of 5 or 5 groups of 3. You can also write multiplication with a dot. You can use parentheses. This form is used a lot. This one is 2. Multiplying two binomials could look like this. X plus 3, then we'll multiply that, times, so let's say x plus 5. Problem is, it looks too confusing because one of the x's is a multiplication sign, while two of the x's are variables. So, multiplying two binomials normally is written like this. X plus 3 times x plus 5. And notice no multiplication sign is needed between the two of them. It's an abbreviation. It's easier to understand the meaning of this, x plus 3 times x plus 5, if we get rid of the x's and put some number in the place of x, like this. We'll take out those x's, and well, we could put 5's in, for example. So now it looks like 5 plus 3 times 5 plus 2. If there's not a variable such as x in there, then it's no longer called a binomial. It's just two numbers being added together. But replacing x with an actual number gives you a good idea of what the binomial could represent. We could replace x with, let's say, 7's. Or maybe this. We could put in 4's. If we put 6 in the place of the variable x, like this, and we add the numbers inside the parentheses, we get a fancy way of writing this, 9 times 8. Which could also be written like this, 9 times 8 with a dot, or x, 9 times 8, 9 times 8. There's a lot of ways you can write 9 times 8. One thing you'll see a lot of when multiplying binomials is this, x squared. It's easier to understand the meaning of x squared if we get rid of the x and put some number in the place of x, like this. We'll take the x out and put in, let's say, a 5. 5 squared. Or this. We'll take away the x and put in a 10. Now it's 10 squared. Let's consider some pictures of 10 squared, 9 squared, 8 squared, 7 squared, and so on. A 10 by 10 square contains 100 little squares. 10 times 10 is called 10 squared because the picture makes a big square. 10 squared is written like this, 10 with a little 2 up high, because two 10s are being multiplied. Inside 10 squared, you can fit a 9 by 9 square. That's 9 squared. And you can also fit two 1 by 9 rectangles. There's 1 times 9, there's 1 times 9, and you can also fit a 1 by 1 square. That's just 1. If you start with 9 squared and add 2 times 9 to that, here's 2 times 9. Now let's add it on. Okay. And then add one more. You end up with 10 squared. Here's a mathematical way of writing this. 9 squared plus 2 times 9 plus 1 equals 10 squared. Here we see 10 squared containing 9 squared. And if we look at just the top row of boxes, we see a picture of 9 plus 1. If we look at just the first column of boxes, we see another picture of 9 plus 1. Here are two rows of 9 plus 1. There's one row and there's another one. Now we have two rows of 9 plus 1. Here's the mathematical way to write two groups of 9 plus 1. 2 parenthesis 9 plus 1 end parenthesis. The multiplication sign, that x there, it's not needed with this abbreviation over here. You don't even need the x. We just know that we're going to multiply. It's an abbreviation. How many red squares are there? Well, you can look at it and count. There are 18 red squares because 2 times 9 is 18. Now we will use a more advanced way of counting the boxes. Down below here, let's multiply 2 times 9, and that's 18. This is the first step in using the distributive property. You may have heard of the distributive property. When a teacher distributes a piece of paper to every student in the class, every student gets a paper. And when multiplication is distributed to every number inside the parentheses, every number inside gets multiplied by the number outside. So you have 2 times 1, and 2 times 2, and we'll add to that 2 times 3, add to that 2 times 4. And it equals 20 altogether. Well, back to our picture. How many yellow boxes are there? Well, you can see there's 2 of them, and also 2 times 1 is 2. Down below, multiply 2 times 1. That's the second step in using the distributive property. Now the question, how many boxes are there altogether? Well, we can multiply 2 times 9, that's 18 of course, and we can multiply 2 times 1, that's 2, and then add them together, and that gives us 20. And that's the third step in using the distributive property. We know that this is true because 2 times 10 is 20. That's something we already know. And there's a picture of 2 times 10, same as 2 times 9 plus 1. When there are two numbers inside the parentheses, we call this the first number, and this is the last number. When using the distributive property, we multiplied 2 times the first number, and then we multiplied 2 times the last number. The distributive property works the same way for 3 groups of 9 plus 1. So here's 3 groups of 9 plus 1. How many red boxes? Multiply 3 times 9, 27. How many yellow boxes? Multiply 3 times 1, that's 3. How many altogether? Add them. 27 plus 3 more equals 30. Here's what we did. We multiplied 3 times the first number, and then multiplied 3 times the last number. Now, let's look at 9 groups of 9 plus 1. This will be a little different. Here we go, 9 groups of 9 plus 1. How many red boxes? We multiply 9 times the first number, that's 81. How many yellow? Multiply 9 times the last number, that's 9. And then add them, 81 plus 9 equals 90. Notice 9 groups of 9 is 9 squared. So now let's multiply 9 times the first number, but instead of saying 9 times 9 is 81, we'll say 9 times 9 is 9 squared. And then multiply 9 times the last number, that's 9. Add them, 9 squared plus 9 equals 90. 10 across and 10 down creates a framework for a 10 times 10 square. You can also say it's 10 by 10. 9 plus 1 across and 9 plus 1 down creates a framework for a 9 plus 1 times 9 plus 1 square. A 9 plus 1 times 9 plus 1 square is the same as 9 squared plus 2 times 9 plus 1. 9 squared plus 2 times 9 plus 1. So to make an equation down below, we could say when we multiply the binomials, 9 plus 1 times 9 plus 1, it's the same as, or equal to, 9 squared plus 2 times 9 plus 1. We can see from the picture that's true. A 10 by 10 square, or 10 times 10 square, also has 8 squared inside of it. Eight plus 2 across and 8 plus 2 down creates a framework for an 8 plus 2 times 8 plus 2 square. If we look at just the top row of boxes, we see a picture of 8 plus 2. If we show, let's say, 5 rows of 8 plus 2, we can use the distributive property to count the boxes. So we'll do 5 times 8 plus 2. How many purple boxes? Multiply 5 times the first number. 5 times 8 is 40. And how many yellow boxes? Multiply 5 times the last number. 5 times 2, which is 10. How many altogether? Add them, and we get 50. We can also use the distributive property to count 8 rows of 8 plus 2. Eight times 8 plus 2. Here we go with the distributive property. How many purple? 8 times the first number, 64. How many yellow? 8 times the last number. 8 times 2 is 16. Add them, and we get 80. We know there are 80 altogether because 8 times 10 is 80, and that's the same thing. Here's another way to use the distributive property to count 8 rows of 8 plus 2. Instead of writing the actual amount, we'll write a description of the amount. I'll show you what I mean. When we do 8 times the first number, instead of saying that's 64, we'll say that's 8 squared. That's a description of 64. And when we multiply 8 times the last number, instead of saying 16, we'll just call it 2 times 8. And then we add them together. When we do add them, we get 80. Let's compare the two ways of using the distributive property. Over here on the left, we have 8 times 8 plus 2. 8 times the first number, 64. 8 times the last number, 16. Add them equals 80. Now on the right, same idea. 8 times this binomial 8 plus 2, or binomial look-alike. 8 times 8, and we'll call it 8 squared. And we'll call that 2 times 8. We add them together, and we still get 80. 8 plus 2 equals 10. Whether you're going across or down, it's still true. 8 plus 2 is the same as 10. By the way, equals is not just an answer word. Equals means is the same as. 8 plus 2 is the same as 10. 8 plus 2 times 8 plus 2 is the same as 10 times 10. So we could multiply 8 plus 2 times 8 plus 2 equals, or is the same as, 10 times 10. We can look at it again a different way. There's 8 squared. There's 2 times 8. 2 times 8 again, and 4. So if we look at all the parts, we've got 8 squared, 4 times 8, and 4. We add them all together. And first we can multiply. 8 plus 2 times 8 plus 2 equals or is the same as 8 squared plus 4 times 8 plus 4. We can see that this is true. Now, we'll use the distributive property in a more advanced way to count all the boxes in the 8 plus 2 times 8 plus 2 square. First, we'll separate the square into two sections. Let's change the picture a little bit here. There. So now, to count these boxes on the top, we will use 8 times 8 plus 2. And to count these boxes on the bottom, we'll use 2 times 8 plus 2. Okay, let's start on the top. 8 times the first number, 64. 8 times the last number, 16. Add them, get 80. Down below, 2 times 8, that's the first number, 16. And 2 times the last number is 4. Add those, we get 20. Now let's take the 80 and the 20 and add them together. We get 100. This can be done a different way. When we multiply 8 times the first number, instead of calling it 64, we'll call it 8 squared, because it is. And when we multiply 8 times the last number, we'll just add 2 times 8. Down below, multiply 2 times the first number. We'll just call it 2 times 8. And multiply 2 times the last number. And we'll say that's 4. Now, add them all together. 8 squared plus 2 times 8 plus 2 times 8 plus 4. We'll rewrite the 8 squared and the plus 4. Now, look at the yellow ones in the middle there. We'll combine like terms. 2 times 8 combined with 2 times 8 makes 4 times 8. To use the distributive property without separating the square picture into two sections, we'll do it like this. We'll imagine first that the 2 is not there. Okay, we'll just erase it in our imagination. And then we'll multiply 8 times the first number and then multiply 8 times the last number. Then we'll imagine that the 8 is not there. So we'll pretend that's gone. And then we'll multiply 2 times the first number, and then multiply 2 times the last number. So we'll do 8 times the first number, 8 times the last number, and then 2 times the first number and 2 times the last number. Now, let's use the distributive property in the more advanced way. 8 plus 2 times 8 plus 2. 8 times the first number gives us 8 squared. And 8 times the last number will add 2 times 8. Now, 2 times the first number, that will add another 2 times 8. And 2 times the last number, so we'll add 4 on the end. We'll rewrite, combine like terms, 8 squared plus 4 times 8 plus 4. To show the whole equation, we'll multiply 8 plus 2 times 8 plus 2, and that equals, or is the same as, 8 squared plus 4 times 8 plus 4. The picture shows that is true. Now, we'll use the distributive property for 9 plus 1 times 9 plus 1. Okay, here we go. Distributive property. 9 times the first number, 9 squared. 9 times the last number, 1 times 9. 1 times the first number, 1 times 9. 1 times the last number, 1. Rewrite. Combine like terms. 9 squared plus 2 times 9 plus 1. Let's multiply 9 plus 1 times 9 plus 1. It equals, or is the same as, 9 squared plus 2 times 9 plus 1. And we'll do one other example. Here's how to use the distributive property for 7 plus 3 times 7 plus 3. Let's see if you can figure out how to do it. What do we do first? We'll do 7 times the first number, and what's the result? 7 squared. What's next? 7 times the last number. We'll add 3 times 7. Now what? 3 times the first number. Hope you got that. We'll add another 3 times 7. And what next? 3 times the last number, which is just 9. Rewrite. Combine like terms. Let's see if you get this one. Plus 6 times 7. Yes. And now we'll make the equation 7 plus 3 times 7 plus 3 equals 7 squared plus 6 times 7 plus 9. In case you're wondering, breaking things down in this way leads to more advanced math, which makes inventions in our modern world possible. Starting with boxes that you can see and count and imagine enables you to understand, so it will be easier for you later when the math gets more advanced. When we add two numbers, 8 plus 2 for example, there's a first number and also a last number. When we use the distributive property in that advanced way, such as 8 plus 2 times 8 plus 2, there are two first numbers, the first number over here and the first number over there. There are also two last numbers. We can think of these four numbers in another way. Let's imagine that there are 4 passengers in a car. This is a little weird, but could be useful. There they are, 4 passengers in a car. Now, let's look at them more closely. These are toward the outside of the car, so they are the outer guys. These are toward the inside of the car, so they're the inner guys, the outer and the inner. These are the outer numbers, the outers. These are the inner numbers, the inners. We can describe the 4 numbers like this. There's 2 first numbers, first and first. There's also 2 last numbers, or they can be described like this: 2 outer numbers and 2 inner numbers. We can classify the 4 groups of numbers this way: first, outer, inner, last. first, outer, inner, last. Yes, it spells foil. How weird is that? The letters F-O-I-L stand for first, outer, inner, last. Many math teachers use the word foil, as in aluminum foil, to help students remember which numbers to multiply times each other. Here's how to do the FOIL method, step by step. Multiply firsts times each other, then multiply outers times each other, multiply inners times each other, and multiply lasts times each other. Now let's get x back in the game. Let's remove the first numbers, the eighths, there they go, and put x in their place. There's an x over here and an x over there. Looks like binomials being multiplied. There are still two terms in each binomial, but now one of the terms is a variable, as it should be. We can describe the four terms like this. We have first terms, the last terms, we got the outer terms, and the inner terms. The FOIL method works the same when one of the terms is a variable, such as x. So we multiply firsts, x times x, then we multiply outers, x times 2, then we multiply inners, 2 times x, and multiply lasts, 2 times 2. Now, let's use the distributive property as we did before in FOIL order. First times first, x squared. Outer times outer will add 2x. That means 2 times x. Inner times inner will add 2x, 2 times x in other words. And last times last will add 4. Combine like terms, that combines to make plus 4x. Rewrite the others. And there we have it. X plus 2 times x plus 2 equals x squared plus 4x plus 4. Here's another example using different numbers. First times first, x squared. Outer times outer, plus 4x. Inner times inner, plus 5x. Last times last, plus 20. Combine like terms, plus 9x. Rewrite the others. And we have x squared plus 9x equals 20. The whole equation, multiplying the binomials, that's x plus 5 times x plus 4 equals x squared plus 9x plus 20. Here's a picture to summarize the FOIL method. Let's say we have a big square. The dimensions are across the top x plus 2, and down the side is also x plus 2. So let's multiply first times first. That's x squared, and we see in the picture there's x squared. Now, outer times outer, plus 2x. Inner times inner, plus 2x. Combine like terms, plus 4x. Now let's watch the picture. There it is, 4x. Now last times last, plus 4. Look at the picture, plus 4. Well, that's all for the Part 2 video. Thanks for watching. Please share these ideas with other people who can benefit from them.